Welcome to Math 154 videos. This video is going to go over two common types of tangent line problems. The first is find the values of x for which the tangent is horizontal, and the second one is going to be finding the equation of the tangent line. Now, we need to note first, what does it mean for the tangent to be horizontal? So let's think about, say we had some graph of a function f. So we'll call this f. So for the tangent line to be horizontal, that's going to be something like this. So here's this point, let's call it A. And right at A, we have a horizontal tangent line. So x is equal to A is an x value where the tangent is horizontal. And that just means that the slope of the tangent line is 0. And now that you're looking at the graph of f, you can see that the slope of this line is indeed 0. So that's what we're looking to find. Now, the slope being equal to 0 is equivalent to the derivative of f at that point also being equal to 0. So, for this function over here in our example, which is not, they're not the same function, I just drew a different function over on the right here. But for this function on the left, if we want to find where this is equal to, well, where the derivative is equal to 0, we're going to need to first differentiate. So we're going to go ahead and take y prime, and we know how to do the power rule, so this is going to be 3x squared minus, well, a 2 divided by a 2 is just 1, so we'll have minus 3x, and then we're going to get minus an 18. Alright, now when the tangent line is horizontal, we want to find out where the derivative is 0, because the points where the derivative is 0 are going to be where the tangent line is horizontal. So we'll go ahead and solve this. So we notice we can factor out a 3, so we'll get an x squared minus an x minus a 6, and we want where that is equal to 0. And turns out, if you look carefully, we can factor this into x minus 3 and then x plus 2. Now, 3 is always positive, right? So we can just, in fact, divide by 3, 0 divided by 3 is still 0. And we want to see where x minus 3 times x plus 2 is equal to 0. Alright, and so that's going to give us an x value of 3 and an x value of negative 2. So at x equals 3 and x equals negative 2, that's where the slope of the tangent line is 0, meaning the tangent is horizontal. So the derivative being equal to 0 gives us a tangent line slope of 0, and if the slope is 0, then it's a horizontal line. So we've solved the first problem. So here's our second type of problem. We want to find the equation of the tangent line to the curve at the given point. Now, when we're finding the equation of the tangent line, we first need to find its slope. Alright, because we have our point, so to use a point slope form or the slope intercept form, we're going to need to find the slope. So the slope turns out to be the derivative at the given point. So if we take the derivative of our equation, y is equal to 2x over x plus 1, and then evaluate that derivative at the point 1, 1, that's going to give us the slope of the tangent line at that point. So that's what we're going to do. So let's take y prime. Now we'll notice that y is a quotient, so we're going to need to use the quotient rule. So y prime is going to be equal to the bottom times the derivative of the top, so low d high for those of you that memorize the quotient rule that way. So our low is x plus 1. Our d high, or derivative of the top, is going to be 2, because derivative of 2x is just 2. Then we're going to subtract from it high d low. So our high function is 2x, and our d low is just 1. So we have that, and then all over low squared, which is x plus 1, that whole quantity squared. So there's our derivative, and now you'll notice if we distribute this 2 out to that x and that 1, we're going to have a 2x out front here and a minus 2x, and those are actually going to cancel out. And we're left over with just the 2 times 1. So the 2 times 1 is just 2, and then all of that is over our x plus 1 whole quantity squared. So now we have the slope. Now we want y prime at 1, 1. So if we evaluate y prime at 1, 1, that's going to be equal to our 2 over, well, at 1, 1, our x value is just 1, so 1 plus 1, and that's squared, and so that's going to be 2 over 4, which is equal to 1/2. And this is going to be our value for m. That's our slope of the tangent line at that point. So now we have the slope, and now we have a point, 1, 1. So we can plug this into the point slope form. So that's going to be y minus 1 is equal to our slope 1/2 times an x minus 1. And that's that. If you wanted to, you could distribute out this 1/2 to that x and 1/2 to the minus 1, and then solve for y to get your slope-intercept form. Remember, where y equals mx plus b. But this is also an equation for the representation of a line, so we can still leave it in this form that I have in the box here in our point slope form if we wanted to. So this is the equation of the tangent line to the curve at the given point.